All right, so let's do this example problem together. So Julie drives her car at an average speed of 36.5 miles per hour, and she does it for 3.5 hours. And the question is, how far does she have to drive? So first of all, we can identify some information in the problem. First of all, I know I have this piece of information, 36.5 miles per hour. That miles per hour thing cues me in that that's going to be a velocity. So I'm going to write it down here by this one, 36.5 miles per hour. And then I also know that I have 3.5 hours. And over the hours, that's a change in time. So I'm going to say 3.50 hours. And then my change in distance, how far did she drive? In my question, we're asking how far, so we're looking for a change in distance. So the next step here is to think about, well, distance, time, and velocity. What's an equation that relates those three? And of course, the equation is the velocity equation. V equals change in distance divided by the change in time. Now we're looking for the distance here, the change in distance. So we need to get the change in distance all by itself in the equation before we plug numbers in. So you might be used to in the past of just plugging numbers in and then solving for that. I want you to work with the equation first without putting numbers in. So how do we do that then? How do we get delta D by itself? In other words, how do we undo a divided by time? And of course, the answer to that is the opposite of divided by, which is multiply. So if I want to get rid of a divided by change in time, I multiply by change in time. Now, if I multiply this side of the equation here by change in time, I've got to multiply this side by change in time. And I notice right away that on the right-hand side of the equation, that change in time and change in time cancel out. That leaves just change in distance for this side of the equation. So now I'll write this equation over again without all this crossed out stuff. And I'm actually going to flip the changes to the left side and flip that to the right side. So we say here that the change in distance is equal to the change in time, right here, times the velocity, times the velocity. Now if you need something between those to mean times, you can put a dot there. Don't put x's. X's get confusing. They look like letters instead of x's. But you can also leave that dot out. It means if you put two variables next to it, they mean times. And then so now we can find, we've solved here for the change in distance all by itself. We can now find that distance by simply multiplying the time times the velocity. So I'll show that work here as well. So my change in time is 3.5 hours, 3.50 hours. I'm going to multiply that by my velocity of 36.5 miles per hour. Now when I do this work, I find that I have a change in distance of 128 miles. And that's my answer. Now the work you have to show is all of this stuff. You have to start with V equals D over T. Always start with this base equation and then show how you get D by itself by multiplying both sides by T. Show the new equation written down. Be sure to show that. And then show the numbers plugged in, each of the numbers with units. And then a final answer with units. And the way I figure out the units here, I should have mentioned, is notice I have an hours on top and an hours on bottom. And whenever you have the same thing on top and bottom of a fraction, they cancel. So here my hours and my hours cancel, leaving just miles. And that's why I have miles in my answer. Awesome. So you have two options at this point. You can click here for another distance example. So this first box. Or you can click here if you're ready to start doing some practice on your own. Good luck and good choosing. I'll give you a few seconds to make that decision.